Tons of news to talk about today. Not all of it is leaks and rumors, and not all of it's doom and gloom, but there's certainly some of that. But let's go ahead and start with more of the leaks and rumors category, since a lot of people want to know what's going on with the next GPU generations. And we got a pretty big leak today regarding the release date of RDNA5 and the process node it will probably be using. And the claim is mid-2027 for that release date. Now, when we're talking about leaks and rumors, a lot of it comes down to who is the source of this and what is their track record, if any. So let's dive into that. So I found this at videocards.com. All of my sources will be linked in the video description as usual, but videocards.com is not claiming this from their own insider sources or anything like that. They're just bringing us a series of tweets. So let's talk about that. So basically, we had somebody saying, I now expect next generation Radeon chips to be manufactured at Samsung Foundry, quoting, industry observers predict that AMD will entrust some advanced CPUs or GPUs to Samsung Foundry's 2 nanometer or 4 nanometer process. But then we had Harukaze5719 saying highly doubt for high-end chips. And then with Kepler L2 responding, nonsense rumor, everything taped out on N3P already. Then we have Raw Mango replying with, so release end of 2026, ? And with Kepler L2 responding mid-2027. Now, all of this could just be, you see random comments talking about this kind of thing all the time, except for the fact that Kepler L2 does have a track record of having insider information regarding AMD products. Now, it's not necessarily a perfect track record. It's not that every single comment or tweet from Kepler L2 has come to pass. However, a lot of it has, and most recently, I remember Kepler L2 being one of the sources for some of the initial leaks regarding the PlayStation 5 Pro and some of the specs regarding that, etc. So, in other words, Kepler L2 does have a track record of getting things correct regarding inside information on AMD hardware. And like I said, regarding the PlayStation 5 Pro, etc., that would be relevant to this because we expect the next generation of AMD GPU architecture. By the way, when we're saying RDNA5, we've seen some things saying that AMD might switch over to a UDNA branding for their next generation of gaming GPUs, but a lot of people are still saying RDNA5 since that's what we're used to. So we'll have to wait and see what it ends up actually being branded as when it releases. But basically, we're talking about AMD's next generation of gaming GPUs. And these are, from everything we know, highly influenced by AMD's collaboration with Sony for the next generation of PlayStation. We've seen tons of talks about Project Amethyst, which is a research and development collaboration between AMD and Sony to make sure that the next generation PlayStation is going to be very strong in machine learning and ray tracing. PlayStation's Mark Cerny has talked all about this. And when we saw RDNA4 launching with a lot more ray tracing and machine learning capabilities, that was already being discussed as a big fruit of this collaborative partnership. But that the next push, all the rumors are showing that this is likely going to be another huge step forward in those directions. Because, again, it makes sense. AMD, whilst a huge, multi-billion dollar company, compared to something like Nvidia, for their R&D budget is certainly smaller. So it makes sense that Sony, who relies on AMD for their console hardware, would pool resources for the R&D here to make sure AMD is catching up in those feature sets that Sony has identified as important. So we're expecting the next generation of AMD GPU to have big steps in those directions: machine learning performance, ray tracing performance. And again, like I said, the PlayStation 5 Pro seemed like kind of also like a proof of concept, trying to push in that same kind of direction. Again, some fruit of the Project Amethyst partnership between Sony and AMD. And again, Kepler L2 being one of the original sources of some of those leaks that did end up panning out, again, lending some credence to these types of posts. Again, though, this is not official information from AMD or anything, and any kind of release date, even if this is something that's planned behind the scenes right now, any kind of release date could end up slipping for all sorts of reasons. So even if this is accurate to what's being planned, again, will it end up coming to pass? Always take all of these things as grains of salt, etc. Anyway, but this is interesting because it does at least say that, according to Kepler L2, they're going with N3P, which is a TSMC process. That's what we would have expected to be the default. It would have been a surprise to see them switch over to Samsung. And again, a mid-2027 release date. Again, even if we're just if I was just asked without any sort of insider knowledge, when would we expect the next generation of AMD GPUs? I would have actually guessed mid-2027 or late 2027 myself if you just asked me. And my reasoning for that is just, well, look at how long it takes GPU architectures to come out. It used to be that we might get one pretty frequently, maybe even every year or so. But the last several generations has been more like a 2-year cycle, and signs point to those getting longer gaps between the next generations, not shorter. And so we only got RDNA4 with AMD's 9000 series several months into 2025. So a 2-year gap would already be putting it towards the middle of 2027 anyway. So that's honestly, I think, what would make sense, regardless of leaks and rumors and insider knowledge. So all of this, I think, just shores up things that already would have made sense. So I think this would be a pretty good bet if you're just going to guess what's going to happen, whether or not you have any actual insider knowledge. Now, I am interested to see what happens because RDNA4, I think, was a huge step towards closing some of the gap between AMD and Nvidia when it comes to feature set and performance in machine learning and ray tracing, but it didn't completely close the gap. So, it'll be interesting to see what happens with this next generation. Now, speaking of RDNA4, though, which is what we have currently, one thing I have been really wanting to see, but we just haven't been seeing, is RDNA4-based APUs, because I honestly spend a lot of time gaming on a handheld, like the Steam Deck. And I would have been really interested in an RDNA4-based APU for a mobile gaming system that could support actual like FSR4 upscaling rather than the older upscaling methods. Because when you're in these, power-constrained hardware, running a high-quality upscaler could be a great compromise to get the kind of performance that you want. But honestly, even on a small screen, FSR3 doesn't look great. Now, we're still not seeing any sign of getting RDNA4 APUs from AMD. Now, that could be a sign that they're really all in on RDNA5, and once they get RDNA5 up and running, that'll be when they make the major shift over in APUs. And maybe they see RDNA4 as kind of this in-between where it doesn't make as much sense to kind of double down on. That could be what we're seeing here. But now this isn't from the PC space, but for Samsung's mobile chips, this would be more for like Android phones. We're seeing that Samsung's Exynos 2600 X-Clips 960 GPU is said to use AMD RDNA4 derived architecture. And this would also make sense to go along with features that they're claiming here, because they're claiming up to 2x higher compute performance versus the prior generation. Samsung also claims ray tracing throughput is up to 50% higher, and that the chip adds Exynos neural supersampling with AI upscaling and frame generation. So, in other words, the big boosts in ray tracing performance and the AI upscaling would make sense if they're using some RDNA4-based features. Now, the videocards.com article here is speculating that it's likely a RDNA3-based GPU with some RDNA features kind of backported in, like Sony has done, for example, with the PS5 Pro, where they've taken some RDNA for hardware features, but combined them with older RDNA versions, not really truly RDNA4. Anyway, now, not that I'm expecting this to actually happen, but in terms of just kind of thoughts on this, like, could this end up helping in a PC handheld kind of format? Remember that one of the things I'm excited about with Valve's recent announcements, like the Steam Frame VR headset, is how much they were talking about getting SteamOS running on ARM. And so SteamOS with an RDNA4, chip, I mean, that could be kind of interesting. I don't know if we're actually going to see that here. And like I said, I think we'll probably get RDNA5 based APUs. And like we have rumors of a PlayStation handheld coming up. And it would make sense if that was based on RDNA5 and if what Sony knows, because Sony's going to know more than anybody else besides AMD regarding what to expect from RDNA5. And if they think it's going to be good enough to justify having a PlayStation handheld, maybe that's where we'll start to see some really exciting APUs with machine learning upscaling, etc. Which would be pretty cool. Now, in general, we're seeing a lot of negativity in the PC space right now regarding pricing. We're seeing tons of comments about this. We have PC Gamer running an article titled "PC Gaming Has a Pricing Problem and the Memory Crisis is Compounding It" in a way that's utterly heartbreaking for our hobby. I have students who ask me about like, oh, they're interested in building a gaming PC. And I'm like, well, what's your budget right now? Because at certain price points, like things are looking a little bit rough with the RAM situation. Some enthusiasts are going as far as, let's see, Russian enthusiasts, this is a headline from Tom's Hardware. Again, all my sources will be in the video description. Russian enthusiasts planning do-it-yourself DDR5 memory amidst the worldwide shortage. Building your own RAM is as easy as sourcing your own memory modules and soldering them on empty PCBs. Now, this is interesting. And they mention how cheap it is to get the PCB. The problem is, where do you source the RAM modules? Now, I was trying to think if there's any way that this actually makes sense to save money. And I was thinking, well, maybe if you have like broken RAM, some of the modules might work and you could like harvest those to try to like piece together working RAM sticks, but it's kind of crazy because the actual spot price for memory right now is continuing to increase. This is from TrendForce, so it's already incredibly high and it's just going up. So if you were hoping for things to start coming down, or if you were trying to buy your own RAM modules at their spot price and like throw them on your own PCB, not really looking like it's going to save you any money. And even major PC makers like Dell, Lenovo, etc., are actually struggling to get memory capacity, with some reports showing that they might actually have to delay product launches because they just can't get memory. It's really a shortage issue is the problem. And so all of this is contributing to a pretty crazy situation for people wanting to get into PC gaming right now or to build a new system. So I do want to just remind everybody that honestly, there's one of the greatest things about the PC platform isn't playing new games. It's the amazing back catalog of older titles that can perform well on systems that don't have to be crazy expensive. In fact, I was reading this post on our Build a PC, talking about somebody who actually built a crazy high-end system, thinking about making sure it's future-proof and all the worst-case scenarios and all of that, and yet finds himself just playing the same old games that don't need any of that. So do always keep that in mind. You might not actually need to upgrade your system if you always just play a bunch of older titles that are already running well. Or if you are looking at getting into PC gaming, you are going to see a bunch of people when you ask the hardware enthusiasts, what do you need? Or you look at channels like mine that are benchmarking GPUs, we'll stress test them in the latest games and talk about 12 gigabytes of VRAM is already showing its limits in certain games, etc. But just because that's true does not mean that you can't enjoy tons of great PC games that are maxed out graph settings, but they're older titles, or you're playing esports titles that are easy to run, or you can play the newest games at lower settings and still have a good time. So just always keep that in mind when you're looking at all of the doom and gloom situation, that like you don't necessarily need an AI, you don't necessarily need a nuclear reactor to power your system, although AI data centers might. So this was an interesting headline. AI data centers may soon be powered by retired Navy nuclear reactors from aircraft carriers and submarines. Firm asks U.S. Department of Energy for a loan guarantee to start the project. Now, I found this at Tom's Hardware. Now, I'm going to be honest, this sounds a little bit far-fetched to me because I can't imagine that this is really the best way to try to get the energy for the data centers. Now, granted, I am not actually a nuclear energy specialist, so maybe I just don't understand the situation, but I'm pretty sure that Navy nuclear reactors rely on like enriched uranium or whatever it is that's like weapons grade and then is like highly not allowed in civilian use. Whereas if you built nuclear reactors just for energy purposes, it wouldn't need that. So I don't know. This seems weird to me, but I'm absolutely certain that I don't fully understand nuclear energy. So there's that. But hey, maybe we're going to be doing this. Who knows? Now, Nvidia recently made a bunch of big headlines, which are now kind of getting overturned. I found this at WCCF Tech talking about this not being quite what people thought. About Nvidia acquiring, now would you pronounce this as Groq? I've only read it in text, and that would be annoying if we have Groq like GROCK, which is like the XAI, right, from Elon Musk's AI. But now we got Groq with a Q, which is more about AI hardware. Specifically, it looks like accelerating certain parts of the inference process for large language models. And we were seeing headlines that Nvidia was buying them for $20 billion. However, this appears to be something else that was a little bit more tricky in order to avoid the regulatory process. What if instead of buying the company, acquiring it, and now you're open to all sorts of regulatory regulations, what if you just hire all of their talent and then license all of their IP, but leave a shell of a company behind that you didn't technically acquire? That seems to be the gist of what Nvidia may have just pulled off here. And I think the idea is to shore up, like I said, a certain type of their inferencing process that maybe Nvidia didn't have its own in-house chip that was quite as competitive on that. Now, I'm going to be honest again, I'm more interested in gaming PCs, so I'm not as big of an expert on the AI data center and acceleration, all the various types of acceleration involved there, but it was certainly an interesting story to take a look at. Now, Nvidia in the gaming side of things, we're still seeing RTX 5090s melting connectors, but this one appears to be the worst we've seen so far, or at least possibly, according to videocards.com here. It's certainly the worst looking photos I've seen out of any of this, where I'm used to seeing like when they take off the connector, there's like a melted pin or two. This looks like an actual fire took place, which is pretty awful. So this clearly seems to be a flawed design. Even if it's not a high percentage of systems that are experiencing problems, the fact that we're continuing to see issues, and this one looks pretty serious, just points to there's something not right with this connector design. The overall quote here from the Reddit user who claims this happened and showed the photographic evidence, right? We don't have any reason to disbelieve it. Had this 5090 for about 9 months, but it wanted to celebrate Christmas by roasting over an open fire too. And indeed, it did not just melt. When I started smelling something weird, next thing I knew, it was fully on fire. Posting here since Nvidia instantly removed it over there for the statistic, LOL. But since people asked over there, it is a 3.1 ATX PSU, and yes, the 12-volt 2x6 came with the PSU. It was never used with another card, got it new for this 5090. I don't know if the PSU itself is great. I don't know much from brand to brand PSU-wise, PS 1050 GFM ATX 3.1 version. So this is interesting because it also brings up what connector to use, because there seemed to be a lot of debate over, should you use NVIDIA's provided adapter? Should you be plugging in 8-pin cables to the NVIDIA provided adapter in the GPU that comes with the GPU? Or should you be using the PSU cable that comes with your power supply if it has a 12-volt 2x6 that comes with it? Or should you use some kind of third-party adapter? Like there's all sorts of situations that are possible here, and sometimes people blame one type of cord over another. So I found this interesting, where we had 9 brands respond on whether it's better to use the 12-volt 2x6 cable or the bundled GPU adapter. I found this at videocards.com, but they are quoting this video from Tech Overwrite, so credit there. And it looks like the overall response was split, offering absolutely no clarity to the end user on what you should do. So it looks like from Asus, MSI, and Gigabyte, they fall into the recommend the bundled adapter that ships with the graphics card camp, whereas Silverstone and Zotac recommend the native PSU cable when possible, and Sapphire, Thermaltake, and Gainward Palette said that you can use whatever option. There's no preference. Now, my thought on this is if it's a properly designed cable standard, it shouldn't matter which one you use. They should all just work. And the fact that we're still showing electrical fires and melting taking place says that something is not quite right with this design. So I don't know, is our next generation of cards still going to be having this issue? Again, I haven't had any issue with my cards. But that's just a sample size of me. This certainly doesn't seem to be a high percentage of users, but it's a non-negligible one considering that there's this constant, steady trickle of photos like this coming out. And I really hope there's some sort of change with our next generation of graphics cards, at least ones that are trying to draw 600 watts. Although we have seen a few reports on, there's a couple of 9070 XTs that use this cable, and they're not immune to reports of melted cables. So they're, again, and they're not drawing 600 watts. So there's got to be something going on here. Anyway, as far as upcoming stuff I'm actually kind of excited about, the monitor space is continuing to show a lot of advancement and are not necessarily hit by the crazy pricing issues we're seeing with a lot of other PC components that are more RAM dependent. So there's that. Now, Samsung has unveiled a new line of Odyssey gaming monitors with some groundbreaking specs. We're seeing a 6K 3D and ultra-high resolution display, as well as some other specs. Now, one of the most interesting ones here is this Odyssey 3D. So what is this? So I still remember, because I'm old, when 3D TVs and 3D monitors were supposedly going to be the next big thing, and then they never really quite took off in the way that I think the TV makers wanted them to. Because oftentimes you needed to wear glasses. It was kind of a weird sort of situation. Now, this Odyssey 3D monitor actually is interesting in that it's glasses-free 3D. And the way that that's going to work is it has eye tracking built in. So it can tell where you are physically, and then it can adjust what it's doing on the screen to apparently have a pretty comfortable glasses-free 3D setup. And this is pretty interesting. Now, I wonder if those older 3D games that were coming out around that time that had support for this would actually work, or if I'm curious what the game support's going to look like for this. Now, we definitely have games designed for VR headsets, which are doing 3D. But again, games designed for VR aren't necessarily going to play well on a flat screen because they're not designed for the for that. Now, I know that there's various mods out there to try to mod 3D support into games, etc. So I don't know. I'm just wondering if something like this could take off again and we could start seeing flat screen displays rather than VR headsets, but that have 3D support, but glasses free. Now, to take over the gaming's business, I really think that too many games are designed around consoles and TVs and a living room setup for this to really make a big push unless TVs started switching back to this. And I think the problem with that is that if this is designed around eye tracking, it sounds like this is still going to make sense for one user. And in a TV environment, I still don't think that makes a lot of sense, and because I just don't see the same type of technology working well in a living room setup where there could be multiple people watching the screen at the same time. So I'm not sure this is going to be the rebirth of 3D, but it's certainly interesting. So anyway, we also have LG coming in with some new advancements. They're showing off an RGB stripe OLED panel, still running at 240 hertz with 480 hertz dual mode 4K. Now, what's interesting about the RGB stripe OLED? Well, one thing that people haven't liked a lot about OLEDs is that their subpixel structure doesn't line up super well with what's expected within Windows for text clarity, because Windows has some clear type stuff where it helps text be super sharp looking, and it relies on the subpixel structure. But since WOLED monitors didn't have that same expected subpixel structure, text clarity isn't ideal. Now, I'll be honest, on a 4K WOLED, I don't really have issues with it. But the lower the resolution, like on the 1440p displays, you can see a little bit of fringing. It kind of depends on you how much it bothers you, but we're looking at seeing this RGB stripe subpixel structure now being supported on this kind of design. Now, I'm curious what that'll mean about brightness, because the reason we were seeing the W OLEDs happening was to help boost brightness. So maybe they feel like they've got brightness solved now at this point and they can do this, but how bright is it going to be compared to the WOLED panels? I don't know. We'll have to see. LG also has a 27-inch 5K mini LED, which I think does have the dual mode 1440p that I was talking about in a previous video that I thought was interesting. Now, again, that's mini LED, not OLED, which has its own pros and cons. And then a 39-inch 5K 2K OLED as well. So interesting stuff coming out in the monitor space. Now, because some of these monitors have insane refresh rates, like the Samsung panel, they have one supporting 1040 hertz speed. That is pretty crazy. So how do you test blur on something like that? How do you see what that does for motion clarity? Well, we do have Test UFO 3 out now, which brings some improvements, including native 1:1 resolution mode and 1000 hertz plus support. Now, this is for looking at, I'm sure you guys have seen this if you're interested in monitor tech at all, but you look at the little UFO slide across the screen and you can then measure the motion clarity. Now, I'm really interested because there's been discussion on how many hertz is enough for essentially perfect motion clarity. Now, obviously, more goes into more goes into motion clarity than just the hertz, but it's certainly a big part of it. So 1000 hertz has been mentioned as potentially kind of the perfect motion clarity. You don't need to go beyond this magical number. Now, getting games running at that speed is a whole other thing, but we can at least get our little UFO to move there to at least measure this monitor technology. Now, some esports titles are certainly getting to around that kind of refresh rate at least. And I mean, there could be some discussion of, is this a good use case for frame generation, where if you have the game running at 240 hertz and now you go into ×4 frame gen or something like that, you already have enough responsiveness because the game is running at an insane frame rate already, and then you can generate frames out to like 1000 hertz or so. I don't know. We'll have to see what the future is going to look like for high refresh rate stuff. Now, as far as things coming out potentially next year, we might actually see Star Citizen, not the full release, but their Squadron 42 single-player campaign. Apparently, it's now fully playable. It's over 40 hours in length and is still on track for a 2026 release date. Haven't they passed like $1 billion in funding now or something like that for Star Citizen? I don't know, guys, but hey, I might check out Squadron 42 if it ever actually releases. Now, in the other gaming space news, sorry I'm like struggling to speak today, guys. I don't know what's up with that. But anyway, we do have the EA buyout continuing to move forward through the various potential hurdles, with EA shareholders officially saying that they do indeed want lots of money. So they have approved the publisher's $55 billion sale. Now, there's still more stuff to go through before any of this finalizes. I believe it's expected to go through in the first quarter of fiscal year 2027, but that is indeed moving forward. All right, let me know what you guys think about all of today's news in the comments section. I hope you guys found the video useful and or interesting, and I hope all of you have an excellent day.